All right, today we're jumping into something that is literally shaking up the very foundations of mathematics. I mean, this is an idea so deep, so profound, that some people are calling it a new alphabet for reality itself. So yeah, let's get right into it.
So, here's how we're going to tackle this. First, we're going to start with a question that seems almost too simple. What does the equal sign really mean? Then, we'll get to know the visionary mathematician who kicked all of this off. After that, we'll unpack the core, kind of mind-bending idea. It's called the univalence axiom. We'll see how it connects completely different areas of math, and finally, we'll get to the big payoff, why this super abstract concept is actually a new superpower for math and computer science.
Okay, so let's start with something we all think we know, right? Something from, like, first-grade math class, the concept of equals. It seems so straightforward, doesn't it? But as you're about to see, poking at that one simple idea, well, it opens up a whole new universe.
No, seriously think about it for a second. When you say two things are the same, what do you actually mean by that? Do you mean they are literally the exact same object, identical in every single way, occupying the same spot in the universe? Or do you just mean they have the same properties, the same structure, that they pretty much behave the same way? That little distinction right there, well, that's the key that unlocks this whole thing.
And this is where Univalent Foundations comes in. You can think of it like a completely new operating system for all of mathematics. See, for more than 100 years, math has been running on this one system called set theory. And it's basically a language of collections and elements, like sorting everything in the universe into different boxes. Univalent Foundations, it's a totally different approach. It's a powerful alternative that does something incredible. It connects the cold, hard rules of logic with our gut feelings about shapes and spaces, with geometry.
Now, an idea this huge doesn't just pop into existence, right? It takes a special kind of genius, a truly visionary mind, to see connections that pretty much nobody else was seeing.
And that mind, it belonged to Vladimir Voevodsky. We're talking about a Fields Medalist here, which, for those who don't know, is basically the Nobel Prize for math. So Voevodsky was this brilliant guy working right at the crossroads of a bunch of super complex fields. And he realized, you know what? We need a better, stronger foundation for the kind of math we're doing today.
So here's the mission. Voevodsky's big goal was to create one single new foundational system for everything. A unified framework that felt more intuitive, something that actually matched how mathematicians think and work in the real world. He wanted a system that could handle all the wild, abstract structures they deal with every day, without getting tangled up in these old, clunky rules.
And that brings us right to the heart of the matter. This is the absolute core of Univalent Foundations. It's a single idea called the univalence axiom, and its whole job is to completely redefine that simple little equal sign we've been talking about.
Okay, so the core idea sounds simple, but trust me, the implications are massive. In this new system, when you say two things are equal, it's not just a boring true or false answer. It's not just a thumbs up or thumbs down. No, the statement of equality is rich. It's packed with information. It actually contains the how and the why these two things are the same.
So check this out. On the one hand, you've got traditional equality. It's super rigid. It asks, are these two things the exact same object? And the answer is just yes or no. That's it. But on the other hand, you have univalent equality. It says, hey, if two objects are equivalent, if they have the same structure, the same properties, then for all intents and purposes, they are equal. You can just swap one out for the other and nothing breaks.
And look, this isn't just some philosophical word game. What this axiom does is create a formal mathematical rule for something mathematicians have been doing by instinct for centuries. Treating things that are basically the same as if they are the same. Think about it. When a mathematician proves something about one triangle, they automatically know it's true for every other triangle with the same properties, right? The univalence axiom just takes that gut feeling and bakes it right into the fundamental laws of math.
All right, so we've got this powerful new way of thinking about equality. The big question is, so what? What do we do with it? Well, this is where we get to see its real power, because this one idea builds a truly stunning bridge between worlds of math that people thought were completely separate.
So, Univalent Foundations beautifully weaves these three different areas together. It all starts with something called type theory. The easiest way to think about this is like the basic grammar and words of the language. It's how you sort everything into different categories. Okay, simple enough. Now, Inside that language, logical statements, things like, if A is true, then B must be true, those are represented as types. And now, here comes the magic leap, the really cool part. Those types can be treated as spaces, like actual shapes from topology, the study of shape and form. All of a sudden, a logical proof isn't just a boring string of symbols on a page, it has a shape. It has a geometric form. How cool is that?
And this beautiful, unified framework, it has a name. It's called Homotopy Type Theory, or just HoTT for short. This is the real-world toolkit that brings the whole idea of univalent foundations to life. It's a system where logic, types, and spaces aren't separate things anymore. They're all just different faces of the same idea.
Okay, I know. This all sounds incredibly abstract, right? But I promise you, this new framework isn't just some quirky idea for mathematicians to debate. It's a genuine superpower, and it has very real, very practical applications, like right now.
So why does this really matter in the real world? Well, it makes the process of doing math with computers way, way better. I mean, a modern mathematical proof can be thousands of pages long. That's way too complex for any single person or even a team of people to check for mistakes. It's just not possible. But with HoTT, we can use these amazing computer programs called proof assistants. You might have heard of them, like Coq, Agda, or Lean. And they can check these monster proofs with absolute total certainty. We can know for sure that there are no hidden mistakes.
When you get right down to it, this whole thing is about the power of abstraction. Univalent Foundations gives mathematicians this incredible new language to see these deep, universal patterns that connect totally different fields. It means they can prove something over here in one area of math, and because of this idea of equality is equivalence, they instantly know it also works over there in a completely different area. Now that is a superpower.
Which brings us to our final and maybe most profound question. If math is the language we use to describe reality, and we've just created a fundamentally new, more powerful version of that language, well, what new secrets about the universe are we now able to express? What new discoveries are waiting for us? What incredible structures have been hiding in plain sight all this time, just waiting for us to find the right alphabet to write them down?